Thank you for joining this webinar. I know you all have busy life and everything during the COVID. I hope we are getting out of this COVID if we don't have this Delta variant rampaging in some areas. So thank you wherever you are. Good morning, good afternoon, good evening to all of you guys. What we are going to talk about today is an easier way to do disaster recovery for distributed applications, distributed cloud native applications running on Kubernetes. And what that means is that Kubernetes is, from our point of view, is becoming the so-called application infrastructure service. You know, we have all been familiar with application servers like Java application servers of wide variety. And here we are talking about an application infrastructure platform that enables a lot more distributed and a lot more scalable applications that are automatically managed to an extent. Of course, it becomes complex and complex as we move along, but that's the goal of this discussion. So what is that infrastructure? And how can you achieve application resilience, container application resilience in particular, are running on those distributed infrastructure. Quick intro, I'm Govindra Rangaswamy, founder and CEO of Appranix. We specialize in application resilience, in particular cloud-enabled and cloud-native application resilience. We have been recognized as one of the cool vendors in this space. And we have been completely focused around providing the protection and the capability to recover your application environments from any type of downtime, and what we call that as application resilience. Given that, you know, this particular webinar is focused on Kubernetes applications, and, you know, even if your colleagues or friends who had registered for this webinar who happen to miss this live webinar, do not worry. You know, we are going to record all of the conversations today. We'll post the entire recorded conversation on YouTube so that, you know, you can distribute that to your colleagues and other friends that may be looking for this kind of capabilities in the future. Given that, let's get started. So as you know, Kubernetes in general and containers in general are now an accepted concept. And I'm sure you have been using containers for some time. And the world is going to be a lot more containerized, and it's going to be a lot more prevalent in terms of having an understanding of those containers. In particular, the de facto container orchestration system called Kubernetes has become the common platform for orchestrating all these containers, be it on the cloud, meaning all three top cloud platform providers, such as Google, Amazon, and Microsoft, and others as well as on-prem implementations of Kubernetes for running these distributed applications. What that also means is that these applications are not like the traditional applications, similar to what Java did for the ecosystem of applications, the dependencies, the runtime environment. Kubernetes is doing that for the containers from an application infrastructure perspective. So kind of an analogy for those of you who might be familiar with how Java evolved 20, 25 years ago, and how application service evolved along with it to redefine how applications are packaged and distributed and run in multi-tier applications. Now what's becoming is that those application components, you know, primitive components such as containers, incorporating all those dependencies, library dependencies, removing all the complexities of distributing the applications through so-called DevOps pipelines from development laptops over to the production environment that might be running in an on-prem setup, or even eventually running on the cloud in a distributed way. In all of these settings, one thing is very sure: the application's complexity has only gotten to be a much bigger problem compared to what we might have seen before. So, it's great when you can package those application dependencies in a nice containers that are distributable, that are common across various runtimes, not even worrying about the application operating systems and so on. Now you have to really deal with a different level of complexity, right? The level of complexity where the distributed applications are creating very dynamic and always changing mechanism. For instance, Kubernetes, underneath of Kubernetes, you have the pods and the nodes, and all of that are automatically scaling depending on the load that might be coming through the load balancers, ingress and egress controllers, and so on. And you have the mechanism of the platform provider, the infrastructure platform providers having their own versions, to an extent, lock-in mechanisms built into those platforms as well. So with all of those components and various aspects of this evolution of this platform, what is really becoming is an enablement where cross-cloud, or even more than that, it is an edge-to-hub type of mechanism, right? Where you can develop your applications, right from your GitHub and distribute through your supply chain, your DevOps supply chain, or even supply chain from third parties and others, and combine all of them together so that you can run these applications across multiple different clouds without having to really worry about how the infrastructure is being managed. Of course, that infrastructure component has to be a worry of somebody else's. Maybe the site reliability engineers are responsible for making sure how all these components run reliably, and also reliably across multiple different clouds, be it edge, where you have limited capacity of your infrastructure, or be it hub. When I call hub, this is a central cloud platform such as AWS, Google, and Microsoft, to name a few. And in the future, you might see Oracle clouds and Alibaba clouds, and so do other smaller service providers enabling these distributed application environments, pretty much creating a very vibrant community, if it is not already, community, and making everything, in a sense, a lot more complex as well, right? And eventually, the capability of this platform allows the developers and site reliability engineers to release much faster features responding to the end user customers, right? And which means that in the backend, a system has to really rely on providing reliability in these type of environments, which means that an environment, a platform has to be there to make sure that it understands all the moving parts of this infrastructure, complex infrastructure, and also understand the configurations and the dependencies of those infrastructures, which are dynamically changing based on, one, the customer loads coming from the top, through end user customers, and the auto scaling functionality of Kubernetes scaling the pods and relocating the pods to different infrastructure nodes based on the capacity, based on whatever the auto scaling policy mechanisms are. That is one component of it. And then second aspect is obviously releasing these applications faster and faster. So with that background, when you think about application resilience, in essence, the reliability of the application resilience, the ability of a distributed system to recover from any type of failure fast, right? It is not about recovering from the failures, in the next 48 hours. It is not about recovering from failures in the next 4 hours, or within 24 hours or 12 hours that you might have seen in the early days when applications were run on virtualized systems or even physical systems. The expectations around the application's recoverability is what we call application resilience, similar to what human beings or the countries or our individual systems are coming back from pandemic, right? You call a human being very resilient if he can recover from the pandemic failures of his family, or individually, if he can become, come back from the failures, then we call him as a resilient person, a resilient country. Similar to that, if a system, in particular a distributed system, comes back from those failures really, really fast, then we call those applications to be really resilient. When we talk about a distributed application, we are actually talking about very distributed dynamic environments such as this. As an example, one of our customers who is actually doing about $16 billion in mortgage payments every quarter has an application, a cloud native application like this. It's a real financial services business critical application that is doing a lot of mortgage payments. As you can see, during the pandemic, because of the low interest rates, mortgage rates have come down. So this company is thriving tremendously and increasing day by day in terms of those mortgage payments, which means that the backend business critical application, which is doing the payments, processing, and the document management, all of that is working hard. And it's working hard thanks to the cloud, by using the cloud, right? By using all kinds of services running on the cloud, including containers, including the external data infrastructure services such as RDS, including the platform services that are scaling automatically based on the auto scaling functionality, and also based on the loads balances running and watching the requirement from the end user customers. So in this situation, the biggest question is that how resilient are these applications, especially when they fail, right? Again, segmenting that recovery is two components, right? How fast can you come back, and what is the mean time between the failures? So those two higher level concepts called high availability and protection recovery are the biggest ones that need to be answered. If we can answer those questions reliably in a concrete way, then we can confidently say that the applications are resilient, right? What that means is that that's great from a resilience perspective. The expectation for those customers is that whenever they move to the cloud or cloud native application infrastructures like Kubernetes, the expectations from them is that, very similar to Gmail or very similar to Amazon.com, very similar to Office 365, when you type in Outlook.com, you expect these systems to be available all the time, which is always on requirement. It's becoming kind of the norm when you really dedicate your time and energy and dollars to rewrite your applications. Otherwise, why would you do it? It's not for the fun of it. It's the fun lasts for a few days. And I used to be an engineer. Whenever I got some cool technology, I wanted to learn. Think about C# and Java, and then now it is Go and Python and things like that. It's all great from language and tooling perspective, but that dies down as soon as you hit a problem, right? Where you run into situations where you work hard, maybe your team that is containerizing your environment, containerizing the components, making them as microservices and are ready to run. And you have already proven that these systems are running in your dev environment, apart from your laptops. And now the problem is that how do you make them run reliably, right, on a production environment, along with other services that might be interacting with that environment? That is when the complexity of practicality and the practical limitations around the reliability of the application comes in, because at the end of the day, the site reliability engineers, the cloud operations folks that are managing your system is now resisting, saying that this is all great, guys. I understand that you want to release your applications faster, and I know you have made your applications much more portable and easy to distribute. And I understand the promise of taking a bunch of containers directly from the container storage and distributing quickly, right? Maybe through all the security checks and everything, right? And you're asking me to run this distributed environment. And now if you think about Kubernetes as an application server platform, the latest version can actually run 5,000 nodes, which means that even if you take minimum of 30 to 50 parts, and now you're talking about 150,000 parts that can be packaged and run, right? And if you just take a moment of silence and think about the scale of it, right? Can you imagine a situation where you have about 150,000, right, pods moving around on these 5,000 nodes when the clusters automatically scale? In essence, you can package more and more containers within those pods, making it like 300,000 containers in a largest container orchestration system that is now possible with the latest version of Kubernetes 1.21, right? If you think about it, how do you really manage that, particularly from reliability perspective, which means that there is an uncontrolled cloud resources growth. From an infrastructure perspective, Kubernetes has to acquire more and more nodes, and also really needs to take care of evacuating those parts that might be running into a problem within a particular node of a Kubernetes environment. So which means that while your end user customers expect that always on functionality, there is so much happening in the backend, all through this COVID-19 and ransomware attacks, and maybe more cloud migrations are happening because you might be actually helping your company migrate more and more. With all of that, the expectation has changed. So at the end of the day, we can provide one of those functionality. We can provide one of those helps where the expectation from the site reliability engineers perspective, the centralized application specific cloud operations people perspective, that's what we call the site reliability engineers, they have a ton of work to do, apart from securing the containers and making sure these containers are working and so on. What if you have some help where the system provides you with application-centric mechanism, which happens to give you much better SLA than what you might have come across in the previous generation of systems, right? So there is practical limitation, and then there is help, right? With that, when you think about making those cloud application environment resilient, it is not going to be a static one, unlike the previous generation of protection system, what we call a backup and recovery, backup and restore systems, right? The protection mechanisms need to evolve along with the dynamism of the environment as such. Otherwise, you're not really protecting. You're not enabling the site reliability engineers to protect your applications. What happens if you don't protect? What happens is that it comes back and bites you, because the system fails. Instead of you actually doing some fun work, making new features available and so on, you'll end up working with that SRE to figure out all the dependencies, not only your own component dependency, microservices dependency, but now you have to really understand what else is being affected and where is that critical component, where is that critical configuration for other services as well. And now you have to interact on a call, on a Zoom call, with all the Zoom fatigue and everything. You have to figure out remotely what's going on, right? And that becomes a lot more complex. So that is where the practical limitations come into play, not necessarily because you are able to create those wonderful containers nicely packaged from your laptops and checked into your container storage and everything. That's fantastic. But at the end of the day, you should enable your operations folks to run those microservices effectively. If not, you end up waking up in the middle of the night, just like our SREs and the developers wake up if we run into problems, right? We are a customer of our own system from resiliency perspective, and we understand, all kinds of cloud environment. In fact, we support all three clouds and the Kubernetes platform running on top of that. And you'll have to think about not about the infrastructure. Those services are reliable. So if you think about GKE services provided by Google, Google knows how to run Kubernetes command. I mean, they invented it. So they know how to run those millions and millions of containers spanning across multiple clusters across the world. They are distributing and running it. So your Gmail is available all the time. So they know how to run that application infrastructure service reliably to an extent. But when it comes to your applications, right, you are responsible for providing that resilience. What that means is that your applications are in danger of any of these failures. It could be as simple as a bad deployment. An example for us is that the previous picture that I showed you, where a company is doing $16 billion in financial services payments, mortgage payments, they introduced a very simple change to their enterprise data management system, which took down over a period of 19 hours. The initial reaction from the system was that it slowed down, performance went down, and then eventually it stopped working. Now, they needed to figure out what's going on to understand all the complexities apart from all the moving components of it, right? And what if a system offers a way out, at least to borrow some time, borrow time from your end users? Here is the situation. There may be some data loss, but the system is up and running. Now you can go and repair or identify those problems on the side, work on the Zoom overnight to figure out what really happened, or if there is a way to kind of go back to an environment at a time frame where you could run the systems again, and then think about really fixing that particular deployment. And it's just one such situation. I'm not talking about ransomware attack that happens all of a sudden from a dormant ransomware that might be hiding in your network for months after months, and suddenly one day it wakes up and destroys everything and makes everything kind of inaccessible by encrypting all the drives, including the backup drives. And that is really worst case scenarios. Or, all kinds of really lightning strike is one of the wonderful things that happened to one of the Microsoft Azure data centers in Texas, which took down the entire region in Texas, right? That happens too. Or misconfiguration. So for various reasons, these things continue to happen, and they will only continue to happen faster and faster frequently. And you'll have to really think about all of these right-hand side issues. Damaged reputation is one of them, and apart from your own precious engineering times and resources, right? And there are tools that is help a little bit. They will help in kind of in a patchwork way. Think about the systems that are being protected on the cloud are using existing backup and recovery mechanisms, right? They're all promising container backups, but that is not the issue here, right? It is not the individual component, individual container backup, especially when you have 300,000 containers running. What's the point of backing up these individual containers and thinking about how can I recover these 10 containers from this particular namespace? That is not the issue, right? And then you will have to really think about replicating your data infrastructure. If you're really using some of the platforms, so-called external services for your Kubernetes environments, they might be relying on external services such as RDS or Cloud SQL or SQL server PaaS services on Azure, or Cosmo DB type of services, or BigQuery. Could be any number of data infrastructure services that might be running external to your Kubernetes environment. So the choices are that either backup and restore, some kind of replication, postponing that recovery testing, and so on. And meanwhile, some might suggest that let's do some storage snapshots. Container storage interface is still kind of an evolving standard, but the Kubernetes distributions are implementing that CSI framework from CNCF, right? in that world, cloud native foundation is enhancing this and making sure that CSI implementations are kind of common across these providers. But what happens is that meanwhile, the snapshots are being taken, right? So just imagine if you're running 100 nodes and you have 2 managed disks, persistent disks, backending these container nodes, the Kubernetes nodes per se, then if you want to protect every hour for those containers, then you're talking about 12,500 snapshots at the end of the day, after 24 hours. The question is, how do you really recover this? Because there is no discovery and analysis of the resilience issue that is available from any system now. And you don't want to get locked into this specific backup and recovery because it's very siloed in nature. And it's very difficult to do testing because now you have to, really run another Kubernetes environment. Some of our customers, coming from GKE perspective, they tried doing it. They tried kind of running another cluster in another region, right, in a kind of a minimal way so that, you can let the Kubernetes kind of scale automatically. And after a while, it has gotten to be really, really cumbersome and difficult to manage because they don't know how to manage both clusters, main cluster, production cluster that is running and scaling and dynamically kind of changing, and the SRE resources are going and protecting that. And I'm at least trying to manage that. Now you have to run additional Kubernetes environment. And what to do with upgrades? How, should I upgrade the DR, so-called pilot light environment or what, right? And then you have to now write all kinds of infrastructure as code if you're running on the cloud for cloud-specific infrastructure as code or some kind of a Terraform, along with all the kubectl thing that you might be writing for your container-specific workloads. And what about the network and security services? What about all the firewalls that you might be configuring or the service mesh that you might be implementing? And that's where we came up with a simple service that removes all those pains, right, and to give you the application resilience. So in essence, if you think about before and after, if you were trying to kind of implement some form of backup and recovery as a system, which means that you might be buying a product and you have to implement and then make sure that is highly available in a region. Well, even if you install the backup and recovery system in one particular region of the cloud, what if that region itself goes down? What if that entire cloud account is taken over by a ransomware attack? Guess what? You cannot even get to your own backup and recovery system. So what is the point of protecting that, except the cases where once in a while you can recover some nodes and things like that, right? And then you implement some kind of a DR, then you have to manage the DR. And then you put in a configuration management system. Of course, you might be having a configuration management system. Cloud providers are now providing configuration management systems. That's great. And if you can implement it properly, all the monitoring, logging, observability systems and so on, that's all great. You have to do it from an SRE perspective, no matter what. But at the end of the day, if you end up managing all of this along with a ton of other work, right, how do you make sure your applications are resilient, right? And that's where you might wish that, what if you had a service, I can just log in and recover. Click a button or touch a button if you're using some kind of an iPad. And we have proven this to many, many other customers. We have onboarded customers over a coffee break, literally. It has become our mantra. Our customer success team is held accountable to a degree of onboarding our customers over a coffee break. Of course, you might drink your coffee. Maybe you have a bigger cup. We don't know, but still it's over a coffee break, which means that less than 15 minutes in general, right? Now, it's not us just portraying ourselves as the biggest, silver bullet here. It is the customer. Nothing beats, other than customers telling us all kinds of good things, and that actually gives us gratification, right? So like it motivates us to do better. So Game Changer is one of those codes. And, I'm able to sleep peacefully in the night because Appranix is actually protecting all my environment. This particular CIO is protecting about 175 terabyte of data and all the application components running on Google Cloud, right? And, I can point out many different infrastructures that we are protecting. Anywhere between 25,000 different cloud resource instances to few hundred cloud resource instances. The good thing is that we are a user of a very good, big, dynamically changing Kubernetes environment. And we, Appranix, is a customer of our own system. And we provide 99.9% SLA, which means that if we do not satisfy that SLA, we can pay a penalty. Knock on wood, we haven't paid a penalty so far, right? We have been operating close to 5 years now. So in essence, what we do is that we go and discover this cloud environment, cloud native environment, as well as the cloud enabled environment. We create a cloud time machine. We do that with no agents by backing up all your metadata, configuration, network services, all of that. And we manage the data copies for your environments, including the persistent disk, the persistent claims, and container storage where it goes, where you have stored your containers so that we can recover from those container storage because containers are immutable. Third, we make sure that you can recover your environment in a guaranteed way using cloud native infrastructure as code. In this particular case, Kubernetes specific kubectls as well, appropriately, by automatically writing that infrastructure as code. Right? So essentially giving you the capabilities to not only back up and recover, but also do disaster recovery. So in essence, we have combined that backup and disaster recovery together and provided that as a service, kind of a table stakes capability. And using this, you can now enable a bunch of other use cases. Maybe that you are thinking about chaos engineering experiments, right? Chaos engineering is nothing new. Netflix has been doing it for a while. If you are relying on Netflix and it hasn't come down for a number of years now. But in the olden days, when AWS East region, Virginia region went down, it was a big national news. Oh, Netflix went down. The reason for that was because the storage environment on AWS Virginia region went down because of some kind of a problem, because it couldn't do the snapshots properly. That was the issue. Go back and check, type in Netflix AWS Virginia storage snapshots. You might identify, or you might come across that particular problem almost like 10 years ago, right? Those problems have gone away because Netflix is a proponent of this chaos engineering, right? Where you introduce known faults into your system and see if your system can actually withstand those failures. Go on a monkey going and killing the nodes of Kubernetes, right? And see if Kubernetes can actually evacuate all the parts from that node automatically over to the replica set running in a different node, and try to pack more parts into that node and then slowly pushing those parts into other nodes. Can you imagine that kind of an automatic movement of these parts? Along with this, your containers and service mesh, hopefully taking care of all these network infrastructures automatically, right? That's how the environments are changing. So if you want to do chaos engineering experiments in an enterprise setup, it's a big no-no, because who allows a known fault into your production environment? So what we say is that make a production twin, right? It's a concept, right? It's a production twin, which is basically a nicer way of saying a cloning of your entire environment along with the data, right? A twin of your production environment over to another VPC completely without affecting your production. Now you have a complete copy, production twin copy, where you can introduce all your known faults so that you can stress test that environment to a point where, let's say, you're comfortable 90-95% of it. Now you know what's happening in your system. You're comfortable. Your SREs are comfortable. Now you can go and introduce the same faults, and you can run your chaos engineering experiments right in your production environment. It's easier to convince other people when you have the real data. Data tells the truth. So, now it is possible. So once you get over the basic backup and recovery and disaster recovery, all of that, now you can get to the point where, much more advanced use cases is now possible, right? And that is possible because we take care of that. Let's not talk about pricing and things like that in this particular webinar. So that's overall idea. So now what we are going to do is to jump on a nice demo here, right? So if you look at the demo, what we have done is that it's an application, very distributed application. It looks very simple, where you can go and buy tone socks. Literally, that's what it is. We love socks. It's a well-known Kubernetes open source application. So let me just quickly log in here. I can type myself here. It's like quick one. And if you go into the socks, you can buy all kinds of weird socks, right? And if you look at those socks, it's literally stone, and I'm not going to pay $100 for these, but it's real. It's actually a real website running in the UK, and they were kind enough to open source their application architecture running on the containers in open source. So you can go and buy these socks, all kinds of ones. So the expectation of this system, if you're really kind of looking for this particular sock and you're hitting the button to buy it, and you're adding more and more and things like that, and you just go on here and proceed to check out. Could not missing shipping information. So all right, this is a demo application, so I'm not going to really key in all of that wonderful data here. It is running. The expectation out of the system is that always on, right? And when you go to Amazon.com, you expect Amazon.com to work and be available all the time, right? And that is the type of expectation, which means that the backend of it has to be kind of running all the time. So if you look at the backend, which is in this particular case for demo purposes, we are running on GKE, Kubernetes, kind of one of the best implementations of Kubernetes. And there are a couple of clusters, 2 clusters, production cluster that is running in the US Central. And in that one, you have the workloads. If you look at the workloads, that workloads are kind of microserviced. Some of them are single parts, just a demo stuff anyway. If you look at that production environment, let me look at kind of a graphical visualization of this environment. Look at the pods, multiple pods, and the nodes, and within the pods, if you look at the services, big services in terms of the number of pods and things like that, right? It is the product visualizer. So containers are running and they are connected. So as you add orders in, you can see dynamically the environment growing all the time, right? You can see, it's moving all the time depending on who does what. So I cannot switch back and forth to show you how dynamic this environment is. So it is dynamic, and it's running in the backend. A bunch of nodes in the backend. You can see these nodes are getting created depending on the workload. That's also providing the necessary infrastructure for the Kubernetes GKE nodes in the production environment. And what we are going to do is that we have to protect this environment, and we are going to simulate a mechanism to destroy this environment, right? In kind of a simulated manner. So what we have to do first of all to protect this environment. So assuming that you have an account in Appranix, all you have to do is to go and make a Kubernetes connection. You simply describe your cluster name, description, and we have a special controller that needs to be run in your Kubernetes environment. Once you have it, we understand your Kubernetes namespaces. If you go into namespaces, all the parts and all of that wonderful things will be automatically collected all the time. Only the metadata, right? We do not take your data itself. We work with your object storage. We work with your container storage environment, right? Container repository, so to speak. So it's all yours. We are not touching your application proprietary data. We are only orchestrating all of that, and then managing all the replication, managing all the metadata, all of that together, so that even when you are growing your environments to 300,000 containers and so on, our system doesn't blink, right? It's able to collect these KBs and KBs of data. So if you look at what we do today, we are dealing with million data points in a particular day, million plus, and sometimes it goes up to 1.2 and then comes back a little bit down, but million data points every day across multiple enterprise customers, smaller customers running on GCP, or enterprise customers that have migrated from their on-prem Nutanix environment to Azure, right? They are protecting about 4,900 resource instances every hour, right? So if you add all of that million plus data points at any point in time, being protected by Appranix right now, as we speak, right? And this one environment is one of them as well. Now with that, you simply describe your assemblies. You simply call that as a shock shop. So it's basically we've socked shop application that you protect as an assembly. And that assembly might depend on some external services as well. So if you go in there, that services might be running on regular instances, with firewalls and routes and disks, all of that. So that is also backended with databases. So both are working in conjunction with each other, very distributed environment. Now the question is that what if something happens to my production environment, right? We have a minimal cluster, kind of a pilot light, kind of ready to go. That's the only one if you look at that particular cluster. So this is your production cluster. It's running in the central region. But if you go to the prod Z, A is for production, Z is for DR in the olden days, but it's basically a failover cluster. In that, nothing else is running. It's basically just a simple backup environment. The daemons and things like very simple ones are running here, right? Now, what we are going to do is to simulate that failover to the other side. So for that, I'm going to just naturally bring down that disaster simulation. So I'm going to click this link. We have written all cool cloud functions and things like that. So I'm going to just bring down the function that is running in West. So it's not even connected, but this function automatically brings down, you can see the production cluster. So you go in here, and if you look at it, there are pods that were running. Now you can see these pods are getting destroyed. So you can see pods have warnings. So now if you refresh more and more, those pods are getting killed, right? But so if you go into that environment here, graphically, things can see they are disappearing. So in essence, your cluster is running into trouble, right? And the application as such, you can see, done. So your application is down. Now the situation is that what am I supposed to do? How fast can I bring back this particular application? And all you have to do is to go to container assemblies, click that particular thing, go to your timeline and say, bring back that application really, really fast, and select the cluster, Z cluster, and say recover. That is all you have to do. And then activity automatically gets kickstarted, right? In progress, recovery is in progress. And if you want to watch the back end of it for the platform recoveries, you can also recover the backend. I'm not kickstarting that particular one right now, but the backend infrastructure will get kickstarted as well. If you want to look at one of those nice files, the expanded config is one of the YAMLs that gets kickstarted for the GCP. So, the GCP environment, including the firewalls, the back end of that, the infrastructure as code is automatically written. You can see 1,000 lines of 415. It's a very simple one in the back end. From the financial services type of customers, the system automatically writes 14,000 lines of infrastructure as code, right? Automatically. You don't have to do anything. It's a no-code environment from your perspective. But of course, it's an automated code environment for us. It's our responsibility to make sure that your systems automatically come up wherever they are. So now we are going from production to the East Coast. Can see you saw previously about 4 pod environments. So all the minimal services that were running now, the cards are coming back. So you can see the workloads. This is just a check, just to make sure that you can come back, loop back mechanism. Now you can see all of those environments are coming back. So if you look at the graphical view of this environment, This is the prod Z visualizer. So you can see all these containers are back up and running. The pods are coming back. This is the Z, the DR environment. The nodes are coming back automatically. Those nodes are getting created here. And if you go back and if you go to the VM instance types, the East Coast environment will be running as well. It was previously running on the Central. Now you have to go to the East environment, East Coast-wide GKE containers. GKE nodes are running. So these East Coast nodes are automatically created, right? You didn't have to really worry about was it like an N1 standard with 2 CPUs and whatever the limited configurations are. Did you have to really think about what was the persistent disk size? What was the configuration? It could be thousands and thousands of configurations. And API access, the external API access services. Who can keep track of all of that? What is the firewall between these nodes? What is the ingress and egress services? It's very difficult if you're dealing with 10 systems. If it is extremely complex and difficult when you're dealing with hundreds and thousands of nodes. And it's unbelievably complex when these resources are moving all the time and getting created, getting destroyed, and the cloud service providers are changing all the time, right? And the question here is, how can you restore your application, right? What if this kind of a magic? It's referring to the same domain, and I can simply log in again, right? And I expect the data services to back. All my shopping cart, wonderful socks that I had, holy services, wonderful, right? They're all back up and running. Now, they're all running on the East Coast, right? So that's simple. That is what we call it as easy disaster recovery for your Kubernetes services in a familiar terms. But at the end of the day, we are talking about very complex application resilience. Of course, you have to do backup. What are you talking about? Unless you backed up, you cannot recover anyway. The question is what to back up, when to back up, what's my dependency? All of those wonderful questions need to be now answered, especially when you scale your infrastructure dynamically, especially when the cluster environments continue to change. And that is the complexity. Right? Let me stop here and see if there are questions. You can use the chat box at the bottom to type in. I will notice if there are questions coming in. I'll be happy to answer those questions right now. If I don't know, I will be very, very honest. I don't know. I will ask our technical team to get back to you. You know how to reach us. Please go to www.appranix.com to check out, what we do. And also, you could, just contact us any point in time. And we will also post this entire webinar on the YouTube as well. That way, you can refer when you don't get sleep in the middle of the night. After all the Zoom fatigue is over, right? You want to sleep, and if you still don't get sleep, you can refer to this wonderful webinar, right? Again, setting the fun aside, do you have any questions? The problem with these webinars is that, there's not a two-way communication, right? So it becomes really hard to kind of ask question enable. So the only mechanism right now is that please type in. We have Philip Morgan standing by as one of our staff members, so he can also moderate. So feel free to ask the question. If not, we are here to answer any of your questions later on as well. All right, maybe it's it's complex enough that you'll have to digest all these wonderful concepts and thoughts, and maybe a new subject called application resilience. But again, thank you very much for your time. You had a choice. you chose to dial into our webinar. Really appreciate it. Really, really appreciate it. And have the rest of the day and have a great weekend as well. Thank you very much.